Okay, it seems like we've been reading these graduated cylinder readings on these diagrams for a little bit now. So what I'm going to do in this video is I'm going to go through some of them, and some of them are going to be more advanced. Others are going to be what are going to be required for you to master in order to meet the standard for this section of measuring volume. So what we're doing is we're looking at different graduated cylinders, and we don't know what size they are. But we can relate them to either a big graduated cylinder, or medium graduated cylinder, or small graduated cylinder, depending. And how do we know? Well, we look at the numbered intervals. So as we go through, we can see that we have numbered intervals on each of them, and we have unmarked intervals. So the question is, how do we relate the unmarked intervals into a quantity related to 1 milliliter? Well, we kind of got to use the numbered intervals as a clue to go through, and then from that point on, we can use little division, little mathematics, and be able to decide how much of a milliliter or how many milliliters each of the intervals are worth. So we're just going to do a couple together. I'd like you to kind of make a guess at some of these, and then I'll give you the answer, and then I'll give you a few as a little quiz, and then you can see if you're on the right track. Okay, let's start this one. Okay, so we can see that we have between 30 and 40 is amount of 10 milliliters. But let's count the intervals. We got 1, 2, 3, 4, 5. Remember counting the spaces. So if we were to count up 30 to 40, and we would think each of these is a milliliter, we'd say 31, 32, 33, 34, 35. Well, that doesn't match up, because we should be at 40 by this. So we have 5 spaces on the unmarked intervals, and then we have 10. So we divide 5 into 10, therefore each of these intervals is going to be 2 milliliters. So this will be kind of a large graduated cylinder. So if each of these is 2 milliliters, then we go up 32, 34, 36, 38, and then if this interval is 2 milliliters, then half of 2 is 1. So we have up to 30, 32, 34, 36, 38. 38 plus 1 is 39. So this would be 39 milliliters. Yeah, this was kind of a hard one. This is a larger graduated cylinder. Okay, let's go with the next one. So this one we have 9 to 10. This means that we just have this whole interval is just 1 milliliter. So this must be a small graduated cylinder as we're looking at it. All right, so let's see. When we have a small graduated cylinder, we're usually going to report it in 3 numbers. So first, whole milliliters. So we have 9 whole milliliters, as we can see by this number right here. We have 9 whole milliliters. So then each interval, if we count from 9 to 10, we count the intervals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 spaces. So if 9 to 10, that means that is 1 milliliter. 1 milliliter is divided into 10 equal parts, so each of these is a tenth of a milliliter. 0.1 milliliter. So as we count them up, we got 9. So the next number in the tenths, of course, is going to be the tenths of a milliliter. So we got 9.1, 2, 3, 4 whole tenths of a milliliter. So now we want to estimate for our hundredths place, which would be, in our case, hundredths of a milliliter. So it looks to be about half. So if we look at it, if it was down here, it'd be maybe 1 or 2. In close, a little bit before the middle, before at the middle, it'd be 5. A little bit past the middle, it'd be 6. Close to the next line, it'd be 8 or 9. So it looks to be right in the middle. So I assign that a 5 milliliter. So remember, this 9 goes to the whole one. The 4 goes to the whole tenths. And then the estimation is in the hundredths place. Maybe an easy way to figure that out. All right, let's take a look at another one. Kind of marked up that one, but we'll do this one off to the side. All right, so 20 1 to 22, the numbered intervals tell us we have 22, that's 1 milliliter. So it might be the same as the previous, so 1 milliliter is divided up into how many parts? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the unmarked intervals here are again going to be 0.1 milliliters. So again, we have our whole milliliters, which are 21. Put our decimal point. How many whole tenths? 1, 2, 3, 4, 5, 6, 7. 7 whole tenths. What do you think the estimation is going to be? Well, it looks to be about 2. It's just a little past that line. 2 or 3 would be fine. Milliliters. So 21.1234567, and then 2. All right. Let's take a look, continuing on at this one. So again, look, we got 30 to 40. This is 10 milliliters on the numbered interval. And then we can count the unmarked intervals. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 on those. So each is a 1-to-1 ratio. So each interval is 1 milliliter. Okay. So here we got an estimation exercise. So we have how many whole milliliters? 31, 32. Because it hasn't gone past this next 33 line. So now we have to estimate. So it's past 5. It's almost the next line. So what do you think the estimate should be? Well, I think a good example would be 8, maybe 9. Either one would be acceptable. I'll choose 8. We got 32.8 milliliters. All right. Let's try another one. What do you think it is? Write it down. All right, let's take a look. How many whole milliliters do we have? Well, we know that we have 20 to 30 is 10, and then again we have 10 equal parts. So it's a 1-to-1 ratio. Each in unmarked interval is 1 milliliter. So we have 20, 1, 2, 3, 4, 5, 6, 7, so 27 whole milliliters. Our estimation looks to be right in the middle between the unmarked intervals. So remember, we're reading from the bottom of the meniscus, so that could be a 5. So we have 27.5 milliliters. Okay. Now this one is still the same, and what do you think it is? Write it down. All right, let's check it out. So again, we have 10 milliliters between the unmarked numbered intervals. The unmarked intervals are again 10 as well, so it's a 1-to-1 ratio. So we have 10, 11, 12, 13 whole milliliters. And it looks to be a little bit past 5, so our estimation could be about 7, maybe 8. Put 7 milliliters. So now these estimation points, if you have it at 7 or 8 or even a 6 in this matter, as long as you're taking into account that, and that's what you're going to need to be able to do to meet the standard. All right. All right. What do you think this graduated cylinder is? Is it a big graduated cylinder? Medium graduated cylinder? Small? Well, it looks like the numbered intervals go up by just 1 milliliter. So it's going to be a smaller graduated cylinder. So we know that when we have these, we're going to have 3 numbers in our measurement. So 1 for the whole milliliters, 1 for the whole tenths of a milliliter, and the hundredths, which is the estimation. So give it a try. What do you think it is? All right. Well, let's take a look. We have 9 whole milliliters. Then we have 1 whole tenth. And the estimation for the hundredths looks to be past 5, maybe 6 or 7. There. So what you got? Now we're still in the small graduated cylinders. Let's take a look at this one. Alright, so we have 13 to 14, again, it's 1 milliliter. Each, we have 10 equal parts, so that's each unmarked interval is 1/10 again. What do you think it is? Write it down. Alright, well, let's see. How many whole milliliters do we have? Well, we have 13 whole milliliters. How many whole tenths of a milliliter? We have 1, 2, 3, 4, 5 whole tenths. Our estimation for the hundredths, it's a little bit past the line, so I'd say a 2 would be the best one. Milliliters. If you had a 3 or a 1, that would also be acceptable for the estimation in the hundredths place. Alright, moving along. What size is this graduated cylinder? Big, small? Well, looks like our numbered intervals are 10 to 20, gives us 10 milliliters. Must be a big one, or at least a larger one. So we have 10 milliliters, and we count the intervals, 1, 2, 3, 4, 5. So if we count up by ones, 10, 11, 12, 13, 14, 15, they don't match up. We have 5 of them, though. 5 goes into 10 2 times, so each unmarked interval must be 2 milliliters. So in this case, we have like 10, 12, and then it's halfway in between, so that would just be 1 to give us, what do you think, 13 milliliters. Yeah. Okay. Let's try some on your own. It will be the quiz part. Write down what you think this measurement might be. Okay, let's see. Well, 0 to 10 is, we have 10 milliliters on the unmarked interval. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10. So 1-to-1 ratio. Each unmarked interval is 1 milliliter. So we have 1, 2, 3, 4, 5, 6 whole milliliters. And looks like it's in between the 6 and the 7, so we'll assign that a 5. Let's try another one. Okay, so this looks to be a small graduated cylinder. This is only 1 milliliter. Is it divided into 10 equal parts? Well, it looks like it is. So we have 10 whole milliliters. Then we have how many whole tenths of a milliliter? 1, 2, 3, 4, 5, 6, 7. And a little bit past that on our whole 7 tenths. So it looks to be maybe a 2 or 3 in our estimation. Milliliters. Is that what you got? You did. You're getting good. Okay. This one looks again that 20 to 30 is 10 milliliters. And we only have, again, 5 intervals. So this must be a larger one. What do you think it is? If you guess 22 milliliters, you're correct, because it goes up by 2. 22, 4, 6, 8, 10. All right, let's try a couple more. Now this is an easy one. You should be able to get this. You guessed 33. You were right. How about this one?